Okay, this is 10.5. I'll work through each problem in 10.5. If you get a problem, you have no problem with them, fantastic. But if you don't get a problem, I'm gonna be just going over each one, okay? Now, whenever you have a polygon, and so really the most difficult problems on this page are 1 through 11. Whenever we have a polygon, we will use 1/2 ANS, but I'm going to redo this 1/2 ASN. Because really an area of a polygon is the area of the triangles that make it up. And when we're looking at this, we're talking about the fact that since I have an octagon, I am going to have 8 triangles, 8 isosceles triangles. All of them are supposed to be the same. And the way I just drew that, they really do not look like the same, but they're all supposed to be 8 identical triangles. Now, if I were to have an opportunity to split this triangle in half like I just did, and I'm talking about this triangle right here has been split in half. So now I'm going to blow that up, and I suppose part of that blowing it up, I should actually have a base to it. The dimensions on this are A. This is a radius. I'm not going to find radius of this. I don't need a radius. Okay, and this is side, or the half side. Okay, remember I cut this in half so it can be perpendicular, and that A is my apothem. Now when I do this, I've got 360 divided by 8, and that's going to give me 45 degrees. Now half of 45 to make this right triangle is 22.5 degrees. So half of the central angle is the angle of this triangle. And that really didn't go well, so we're going to write it again. I'll write it a little bigger and that'll shrink it. So it's 22.5 degrees. And we'll shrink that down. That's 22.5. Now, using that, I am going to find my A because I already know my half side. My full side is 8. My half side must be 4. Okay? Now, to work with my apothem, I'm going to use tangent because this is opposite over adjacent. Opposite over adjacent is tangent of 22.5 degrees is equal to 4 over A. So A will equal to 4 over tangent of 22.5. So now I can put that in my calculator, but I'm going to hold off on that for a second. That's an easier number for me to keep because it is exact. I'm going to get rid of this radius. I did not have to find the radius for this particular problem because I was giving a side and I needed the apothem, a side, and the number of sides. So I had the side measure, I have the number of sides, they both happen to be 8. The apothem is what I just found. So now we're going to use that and plug it back in. I'm going to put my triangle I worked with, back in. I'm just going to lock this part of the sheet in. It's going to lock it down. And we will put that back in. So now I'm going to group these things together and lock that back down. So that's the stuff I was working on right there in this problem. Now, I found 1/2. I knew my apothem. My apothem's right here. I'm going to pop it right there. It is 4 divided by the tangent of 22.5. Okay, that's one of my values. Now, I also know that my S, my side length, is 8 meters, and the number of sides is 8. So those are all 3 of my numbers I'm going to put together. And while we're doing this, I'm going to get my calculator up on the screen so you can see how to get this done with a calculator. Hopefully this will come up quicker than it usually does. So now putting this in my calculator, I got 1 divided by 2, which is 1/2, times 4 divided by tangent 22.5, close my right parenthesis, times 64. That's 8 times 8. And that'll equal 309.019, but I'm supposed to round my answers to the nearest something. Let's see if I can pull this down, nearest tenth. Okay, so my answer here is 309.0 meters squared. Okay, we're gonna get some stuff out of there so we can get to work on our other ones. Probably shrink this down so it's not in my way totally. Well, we're gonna get rid of these for sure. And shrink this down. So if we need to, we can find stuff later. Now, I'm gonna skip 2 for a little bit because we're gonna go down and do the bottom ones, and I'm gonna come back to ones like 2. Okay, in 3, I have a side. Well, I have a side, I gotta find an apothem. So I'm gonna use area is equal to 1/2 ASN. Okay, remember, I find the triangles, area of a triangle, multiplied by how many triangles there are. In this particular case, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a nonagon. So n is 9. So I know n is equal to 9. I know s is equal to 14. I just need a, and I'm going to find a by making it half a right triangle. So I'm going to go half a right triangle to find my a. Keeping in mind that this is a right triangle, and half of 14 is 7. This is a right angle, and I'm looking for my apothem. I got to get that angle value where I know that 360 divided by 9 is 40. So this is cut in half because I cut the triangle, the central angle, in half. So now this is a 20-degree angle. And now I use, again, tangent. So I have the tangent of 20 degrees is equal to 7 over a. And because that's opposite over adjacent. Now, I know a is equal to 7 over tan of 20. And that is my apothem. So I know my apothem is 7 over tan of 20. And now all I have to do is plug that information in. So I'm going to take care of this stuff here. I'm going to group this. I'm going to shrink it down so it's out of my way. Okay, this stuff, my figures I'm going to group. Shrink that down, get that out of my way. Bring that up so you can see it. And now plug in my values. I know I got 1/2. A was 7 divided by tan of 20. S is 14. N is 9. I'm going to move this over so I can get my calculator up here and find my answer. I'm going to use 0.5 instead of 1/2. So I got 0.5 times 7 divided by the tangent of 20, close my right parenthesis, times 14 times 9. And that'll give me 1,211.6. So this is 1,211.6 centimeters squared. Now, each time I'm given a side of a polygon, I must do the same search for the apothem. Okay? So, in a hexagon with side length 4, if I have a hexagon with side length 4, so I have a side length 4, that means I have a 2 half side. So my side length of 4, we're going to slide this over. A 2 half side, that's 4, this is 2. And keeping in mind, I got a little shortcut with a hexagon because remember, this is an equilateral triangle, and if this is 2, this is 2 to the square root of 3 for my height. And that's also my apothem. So I can quickly find this. So in this particular case, area is 1/2 A S N, and I got 1/2. My A is 2 the square root of 3. S, the number of sides, is 6. Excuse me, the length of my sides is 4. And N, the number of sides, is 6. And now I multiply those together, and I'm going to come up with 41.6, I believe. Let's just double check. I got 0.5 times 2, second square root of 3, arrow out, times 24, that's 6 times 4, and I get 41.56. But I'm supposed to have my answer to the nearest tenth, so 41.6. And that is meters squared. Now again, this information that I just did, I'm going to group and shrink down. So I have this information, and we can bring it back up if we need to. But that's the information for that problem. I'm going to do exactly the same thing in 5. Now, in 5, I have a pentagon with side length 10. So I have a pentagon. Tell you what, let's get a nicer pentagon than what I can draw. Let's do this. And I got a pentagon, and I've got a pentagon here. Okay, so we got our pentagon, and we will do a side length of 10. This side length happens to be a 5 side. Okay, that's half. And remember, I'm making a right triangle, and half the side requires this. I'm looking for my apothem. I have to have the angle there. So it's 360 divided by 5, which is 72 for the whole triangle. This whole thing is 72. Half of it is 36. So I'm going to blow this triangle up. Perhaps I need to blow this triangle up better. Let's do it this way. I got to group this triangle here. So now, let's blow that triangle up. Know that this is 36 degrees. I know this is 5, and I know I'm looking for A. So now I'm still doing tangent. Tangent of 36 is equal to 5 over A. So A is equal to 5 divided by tangent of 36. So I have my apothem. So now I've got everything I need. I got my areas 1/2 ASN, and that is equal to 1/2 my apothem is 5 times tangent of 36 times my side length, my full side length, which is 10, times the number of sides, which is 5. So now I can put that in my calculator, and I'm going to slide this over so you can see my calculator calculations, and I got 0.5 times 5 divided by tangent of 36, right parenthesis, times 50, that's 5 times 10, and I get 172.0 for my answer if I round it to the nearest tenth. So my area is 172.0, and I got to find my units here, inches squared. Keeping in mind all the stuff that I did, okay, I'm going to group and squeeze this down. So that way it'll fit in my spot. Okay, and I did use this stuff. I'm going to shrink that down with it. And I used that this was 5. Whoop. Okay, now the things with radius in them, I'm going to skip those. The next 4 have radius in them. I'm going to go to the next 2, problem 10 and problem 11. Well, problem 10, okay, now here's the deal. The ones we've done so far, keep in mind, in problem 1, I was given a side. In problem 3, I was given a side. In problem 4, I was given a side. In problem 5, I was given a side. Each time I was given a side, I worked at taking half that side length, finding the central angle, and taking the half of that central angle to make a right triangle with this half of the isosceles triangle that is created with the central angle to find my answer. So let's talk about this again. I am looking at a 15-sided polygon. I don't care what that looks like. Well, I guess I can. Let's actually make a 15-sided polygon. I want 15-sided polygon, and this is a 15-sided polygon. Maybe if I can get that up right better. Yep, 15-sided polygon. So here it is. This is a 15-sided polygon. Okay, hopefully you can see all the different sides in this 15-sided polygon I just flipped up on the board. Now, a 15-sided polygon, it has a center, and there is an isosceles triangle going up there. These are the same. I am cutting this triangle in half to find my apothem. The black line's my apothem. What's my angle? How do I know the angle? Well, I know that 360 divided by 15. 360 divided by 15 is 24 degrees. Now, that's the size of my central angle. The size of my triangle, now, this is not drawn to scale, but it's drawn in such a way that I can use it. This is half my side. This is a half side. This is a right angle. This is my apothem, and this is 12 degrees because that's half of 24. Okay, now I need more information. I've got this thing that's 120. Okay, but how big is 120? So 120 divided by 15. How big is one side? 120 is my perimeter. Dividing it by 15 gives me a side measure. Each side is equal to 8. So now my half side I know is 4, and it's 4 feet. Okay, I know that's 4 feet because that's 120 feet. Now, I am looking for apothem. And according to the 12 degrees, 4 is opposite, apothem is adjacent, so I'm doing tangent again. So I've got tangent of 12 degrees is equal to 4 over A. And A is equal to 4 divided by tangent of 12. Now, I have my A. Well, if I have an A, I can find other stuff here. Because all I need now is to keep in mind, since I was given perimeter, perimeter is the side length times the number of sides. So now I'm going to use area is equal to 1/2 AP. And I got 1/2 my apothem, 4 divided by tangent of 12 times 120. 0.5. Let me get this up here on my calculator. I can get this going. It's here someplace. So I've got my apothem is 4 tangent of 29, but I got 0.5 times 4 divided by tangent of 12, right, parenthesis, times 120, that's the whole perimeter round, or that's n times s. And that's 1,129.1. So 1,129.1. 1,129.1 feet squared. Let's put that in red, because that's everything was in red for that calculation. We got that made. Now, again, when I'm given a side, there's the same theme going on. I'm going to group these together, get this going on, and that is when I'm provided a 15-gon. Now, an 18-gon, done in a very similar way. It's a 54 perimeter. I don't think I can make one with my board. We're going to check and see if they allow me to. Nope, they just go up to 16. So here's the deal. I'm still working with a triangle, okay? Remember, the main triangle looks like this, okay? I have an isosceles triangle coming from that. I've got to find this angle. That is 360 divided by 18, which equals 20. That's 20 degrees. Cut the 20 in half, and that is a 10-degree angle that is created when I drop the apothem. So this is 10 degrees. Now, that's a right triangle. I know that the perimeter of this is 54. If I take 54 and divide it by 18, I'm looking at 54 divided by 18 on my calculator. 54 divided by 18 on my calculator gives me 3. Each one of these sides is 3, so a half side is 1.5. So now I am looking for my apothem with a tangent of 10 is opposite over apothem, or adjacent. So my tangent of 10 is equal to opposite over adjacent. So my apothem is 1.5 tangent of 10. And notice I'm taking half of the side and half of the central angle to make my right triangle that is half of the isosceles triangle that makes up my polygon. Now, I have that information. I now look at area is equal to 1/2 ANS, ASN, or 1/2 AP, because P is perimeter, and that's the number of sides times the side length, and they gave me perimeter. So now I've got 1/2 times 1.5 divided by tangent of 10 times 54. And I'm gonna put this in my calculator again. And to access my calculator, I just gotta move things over here. So I'm looking at my calculator. I've got 0.5. Let's clear this so you can see which number I'm putting in. 0.5 times 1.5 divided by tangent of 10, close my right parenthesis, times 54, and that equals 229.7. So I have for my answer 229.7 meters squared. Now, those are finding the area of polygons given sides. You had to find the apothem. Okay, those are the finding the area given sides. You had to find the apothem. What I'm about to do is going to get us ready for a radius shortcut. Okay. Now, keep in mind, there are different ways of looking at problems. What we've been doing is finding the area of one triangle, multiplying by how many triangles, and coming up with the final solution, okay? Now, in this next set of 6, we are using one formula. Area of a triangle is 1/2 the two sides that make that triangle times the sine of the angle that those sides make. So the two sides, 6 and 4, make 68 degrees. So I got 1/2 of 6 times 4 times the sine of 68. Well, when I do that, I put that in my calculator and I get that it's 11.13. And let's get that written better. 11.13 meters squared. And that's the area of that triangle. Now, I want you to emphasize on this that I can find the area of a triangle given the sides that make the angle. So I have area is 1/2 base BC sine of A. And remember, BC sine of A, so I have 1/2 12 times 11 times the sine of 33. That is going to come out to be 35.9 inches squared. That's the area of that triangle. Again, it's not going to change. I have a triangle that is made up of two sides that make the angle. The two sides have to make the angle, otherwise it does not work. So I have the area is equal to 1/2 BC sine of A. Well, 1/2 8 times 4.5 sine of 99. And that is going to equal 17.8 centimeters squared. Now, I'm hoping that you're starting to pick up on this formula that finds the area of a triangle. All I have to have is the two sides measure. Okay, I've got the angle, and these two sides make the angle that we know the measure of. So I've got the area of a triangle is 1/2 BC, the two sides that make the angle sine of A. Well, this is going to be 1/2 5 times 9 times sine of 85. And that's going to return 22.4 feet squared. Now remember, as I'm looking through this, I haven't changed the formula at all. Once I know the value of the sides, and the two sides make an angle, and I know that value, I know that area of this triangle is 1/2 BC sine of A. Now, 1/2 is 10 times 10 here, sine of 68. I put that in my calculator, and I believe I come up with 64.4 millimeters squared. But we're going to check this because the sheet I did this on looks a little garbled. I'm going to double check. So I got 1/2 times 100 times sine of 68. And it's 46.4. So I'm not sure where I came up with the other one. Oh, wait, we got to check to make sure my mode's right. Yep, it's second quit, 46.4. So I have no idea what I did wrong with that, but I think I kind of flip-flopped a couple numbers. So we got 46.4, and that is millimeters squared. Now, my last one here. I'm not doing nothing different. I've got two sides that make an angle. Those two sides, with the angle they make, I can find the area of a triangle using this formula. Well, this is 1/2 14 times 15 sine of 125. Whoops, ran out of room. So let's move that over, and let's say that's 125. Now, this comes out to be 86.0 inches squared. Let's just double check because I had that funky calculation on that last one. So I got 14 times 15 for 15. Let's go 15 times 7 because that's half of 14 times sine of 125. It's 86.0. Awesome. Now, here it is. The big kahuna. I just found area of a triangle given two sides and an angle. Let's look at these up here. I have a triangle, and these are radiuses. This is 6, this is 6, and I know that 360 divided by 5 is 72. I have a formula that can help me find the area of that blue triangle. Okay, the area of this polygon can now become n, the number of triangles inside this polygon, it's going to be 5, that's the same as number of sides, times, we just did it, 1/2, and instead of BC, I'm going to talk about the radius squared, because the radius is 6 here on both, sine of the central angle A. So now I have 5 times 1/2 6 squared sine of 72 allows me to find the area of the triangle, this blue triangle, and there are 5 of those blue triangles in this problem. So let's look at what this answer will be for us. Is I don't put my pen in my sill. Okay, so we have 5 times 0.5 times 36, because that's 6 squared, sine of 72, that's the central angle, and that's going to give me 85.59, which is 85.6. So my answer is 85.6. Good gosh, I don't know what in the world in units that is. Hey, 6 feet squared, 0.6 feet squared. Now, that might seem way easier than the other ones, but I want to emphasize something, and it's a mistake that people make all the time. This doesn't work for all of these polygons. This only works when you're provided the radius. I gave you a radius in this polygon I want to get that out of there. I gave you a radius in this polygon of 6. Because I gave you a radius, the radius is the same all the way around. We can use that 1/2 BC sine of A triangle formula to help us easily find the area of a polygon. Now, do you see the ones that we have left? A nonagon with radius 6. Remember, with a radius, only with a radius squared, sine of A, central angle. The radius is 6. That's crazy. But now I've got to do the angle A is equal to 360 divided by 9, which is 40. So now I get my number of sides. Nonagon is a 9-sided figure. 1/2 6 squared sine of 40. And I pop that in my calculator. So I've got 1/2, well, I've got 9 times 0.5 times 6 squared times sine of 40. That's 104.1. Okay, done. That's my area. All right, now, again, this only works when you're provided a radius. If you're given a radius, you can work on this and get her done. If you are not given the radius, you cannot use this formula. You must have a radius. So now, a decagon, 10-sided figure. I'm going to go 360 divided by 10. A is 36. My formula, area is equal to 1/2, the number of triangles. Number of triangles are the number of sides, there are going to be 10 of them, times 1/2. R squared, my radius is 5 here. Sine of A, which we just found, was 36. So I'm going to take 10, 1/2, R squared, 5 squared, sine of, yes, I'm finding the sine of A, which is 36. I pop that in my calculator, and I know it's 73.5 millimeters squared. And I'm just going to try to clean that up because it was kind of messy. 73.5 millimeters squared. Okay, we have 2 left, and I want you to use the formula and see what you know. An octagon is 8 sides. Turn me off, give them a try. Okay, we're back. We're practicing a new formula that only works for radiuses. Area, N, is equal to 1/2 R squared sine of A. Okay, R is the radius of my polygon. N is the number of sides. A is the central angle. 360 divided by 8 is 45. R, they tell us, is 9. Octagon is 8. There are 8 triangles that have sides of 9 squared. Sine of 45. I'm going to pop that in my calculator right now, if I can pull it up. Okay, so I'm looking at 8 times 0.5 times 9 squared times sine of 45. And I'm going to get 229.1 equals 229.1 centimeters squared. Okay, this might seem like it's way too easy, but remember, this is based on something we know. The more we know, the easier things can become, but we have to be able to apply them. If we don't work at stuff and practice it, we don't have this type of application. So we got to keep in mind, as we work, we might come across something and it'll make things easier. Again, let's do it again. If I am provided the radius, I get to use this formula. Okay, 1/2 r squared sine of a. Where n's the number of sides, r is the radius, a is the central angle. The central angle is related to the sides, but being divided by the sides, and each angle here is going to be 18 degrees. Now, I know the number of sides. It is 20. It's a 20-sided figure. It's 1/2. 3 is the radius, so it's 3 squared. Sine of 18. And again, I'm going to grab my calculator out and I'm going to calculate up my answer. 20 times 0.5 times 9 times sine of 18. Sine of 18. And that is 27.8. So this is equal to 27.8 inches squared. Now again, this only works for polygons, regular polygons. They have to be regular, where you're provided a radius. This is 18, I left that out. But you're provided a radius and you can get it done. Now, because we are able to do that, we finished the rest of this sheet as we were going here. Okay, now let's go look at that next page. Now, for this, I'm not going to worry about 18, don't want you to do it. I'm not going to worry about 19, don't want you to do it. Okay, I'm worried about 20 through 25. So, these last ones, look, these radius, radius, radius. I wonder. How many sides does this have? All the triangles in there. How many sides does that have? All the triangles in there. Let's see if you get this new formula that Bloom showed you. And remember, the formula is A equals the number of sides times 1/2 radius squared sine of A, and A is the central angle. Now, with that said, we can do 20, 21, and 22, no problem. Those are going to be graded. The polygons are regular polygons. Find the area of the shaded region. You got to find two things going on here. There are two things going on, and we will probably do these right at the beginning on Monday. Okay, but what I want you to know is that you're going to have a big pentagon minus a little pentagon to find the donut shape of the pentagon. Here, you're going to have a hexagon minus a smaller hexagon to get the gray shaded region. Here, you're going to have a square minus another square. And keep in mind, these are diagonals or parts of diagonals. That's my hint. And you're going to use A is equal to 1/2 diagonal 1 times diagonal 2 to get that done. That's a multiply, by the way. And these other ones should be very reasonable for you to do right now as well. So we won't do these later. We'll do those now. And these 6 are the things that you have left for 10-5 that we'll go over on Monday. Okay, thank you for your time. Have a great day.